So the decision was made in every capital in the first month of the war. We have to stop them here in Ukraine. Now we have to prevent that direct fight with NATO from ever happening, in order to make sure that the nukes stay in their silos. To that end, anything that the Ukrainians can prove that they can operate and maintain. Very, very, very important word, that maintain. The Germans were very explicit on that point. A weapon system that you can only use once is not a weapon system, it's a paper. We operate and maintain, they can have everything else. Details, there are a lot of details. But that was the commitment that the NATO countries made up front, because it's cheaper than rebuilding cities. So we can fight this war with the Ukrainians in Ukraine, or we can rebuild Atlanta and Detroit. That's the choice, it's not a hard one. Now that has some consequences, and the war is evolving. In the last month, the Russians have started fielding these guys. This is what's called a Fab 1500. It's a 1,500 kilogram weapon. It's a dumb bomb that eventually makes a blast radius that is more than a third of a mile across. The problem that the Russians have always had is accuracy. The problem that we have already had is heavy blast capacity. We fight a continent, a hemisphere away from where we're from, so we have to be precise with our weapon systems. So we have better guidance and better intel. The Russians are fighting among a much shorter chain of support, so they go for the big body. What they've done with the F-1500 bomb that has 2 tons of explosive capacity is in the last few weeks they've started fitting them with something called a glide kit. You guys remember back to Desert Storm, we started putting glide kits on our dumb bombs. They were only 500-pound tiny compared to these guys, but that's what allowed us to target bridges and buildings in Iraq with precision. The Russians don't have within an order of magnitude that kind of accuracy. These things only hit 50 to 100 feet, but when your blast radius is 2,000 feet across, that's plenty. We're seeing the Russians marry their sheer mailed fist approach to military ordnance to a degree of precision. And in the battle for Abadiva, they dropped about 300 of these things in a 48-hour period. That's what won them that battle. And we're seeing a fundamentally different Russian military emerge in just the last few weeks. Massive power, reasonable accuracy. We've never had to face that before. Now for their part, the Ukrainians are also innovating with drones. The one at the bottom, this is the Beaver, not a very intimidating name, and the one above it is the C-Day, which is literally made out of operational range of about 600 kilometers. This one carries about a 15 PB bomb, this one carries about a 70 PB bomb. This one is literally built in people's garages and then targeted by the Ukrainian military. And they're using these things to target refineries. They have found in the last 2 months the capacity to gut-punch the Russian economy in a way that none of the sanctions have done so far. The Russian educational system collapsed in 1986. The youngest people in Russia who are worthy of the term engineer turned 64 this year. The ability to repair a fractionating column in a refinery is a limited skill set that the Russians no longer have. And the few people they know who are adjacent to that skill set are in Ukraine as part of the war effort or are building munitions. So we're seeing more and more refineries come offline. But the best part is, this guy up here. This is a Phoenix Ghost. This is an American-made operation. It's man-portable, it's modular. You put it in a backpack with a 10-pound bomb, you hike into Russia as part of a special forces group, you go 1,000 miles from the border, you identify a target, you hand on. Some of the more recent attacks we've seen in the last week are definitely Phoenix Ghosts. And so we've seen lots of refineries go offline. All the oranges are where we've had a meaningful attack, with operations going there. It's not permanent. These things can be repaired, but not quickly, and by the Russians. So they're having to bring in third-party nationals. My guess is that most of those third-party nationals are Chinese, which means we're this far away from the Ukrainians specifically targeting Chinese workers to bust sanctions with American-made weapons. This war is about to get really delightfully okay, so that's really bad from an energy processing point of view. There's also problems on the production side. This is Western Siberia, in case anyone is looking for a summer. Now you want to produce in the permafrost. You guys, we're no high. You guys don't know permafrost. If you go far enough north and get into cold enough territory, you get into a zone where the ground never really thaws. In the wind and in the summer, the top layer will thaw. You'll get something like this. They're called thermal lakes. If you want to produce something in this zone, what you gotta do is wait for it to freeze solid, which in Russia means like months of the year. Then you run a BM out through hundreds, if not thousands of miles of empty territory. You run a piece of infrastructure down the middle of it, a pipe, a road, a rail line. While everything's frozen, you drill on a drilling platform because you can't drill when it's melted, you can't drill through swamp, and then you produce, so these are the highest upfront costs for material development on the plant. Unfortunately for the Russians, it's a dynamic landscape, so if a fault opens up and everything drains, it drains to the side and you get a massive slip, or maybe it drains down, in which case you get a sinkhole, or maybe you have a very, very warm summer, and some of the permafrost melt deeper, and then when it refreezes, when water freezes, it expands and you get a bubble in the land. These are all really bad for infrastructure. And remember, the Russian educational system collapsed a long time ago. The Russians have the highest maintenance costs in the world. And most of this work for the last 30 years hasn't been done by them, it's been done by Exxon and BP and especially the Dutch and the Germans, and all that work stopped when the Ukraine war again could be sanctions, could be war damage, could be lack of maintenance. We need to prepare for a world where all of the materials coming out of Russia don't make it. Alright, compare that to us. I like to call this the checkbook map because every dot up there is someone who paid their power bill. Here are 3 concentrations of checkbooks. You got the Austin-San Antonio quarter down below where I used to live. You've got Midland, Odessa in West Texas, and up top the cultural Mia that is Bismarck, North Dakota. But what are these? Meet America's shale fields, meet America's oil shale fields. So much natural gas is bubbling up as a byproduct of these 3 oil PLS that they have to flare the gas, until such time as they can build out the infrastructure to capture it now. In the United States, we have the world's largest and most versatile natural gas gathering, distribution and usage system. But we can't keep up with the pace of the oil shale drillers in these 3 zones, and so, until the infrastructure can be built out, you can see the flares from space now. Why are the Marcellus and the UTA so unique among the shales? This is a question that piques the curiosity of many energy enthusiasts. Their uniqueness lies in the fact that they are primarily natural gas plays. Unlike in Texas or North Dakota, where the focus is on oil extraction and natural gas is often sold at a loss merely to dispose of it, the situation is reversed with the Marcellus and the UTA. Here, the primary objective is the extraction of natural gas. This is because cities from Chicago to Boston to DC are majorly powered by natural gas electricity. It's this clean, efficient energy source that keeps these bustling metropolises running day in and day out. But what happens to the byproducts of this extraction process? During the extraction of natural gas, certain byproducts come to the surface. These are known as natural gas liquids, or NGLs for short. While the name might not be the most inventive, these byproducts are vital components in our daily lives. They include substances such as propane and butane, familiar names to many. Rather than being discarded, these NGLs are integrated into various other systems and processes, adding value in unexpected ways. The process of natural gas extraction is a fascinating one. It involves drilling down into the earth to the shale formations where the gas is trapped. Once the well is established, a mixture of water, sand, and chemicals is pumped into the well at high pressure. This process, known as hydraulic fracturing or fracking, creates small fractures in the rock through which the natural gas can flow. The gas is then collected and processed, with the NGLs being separated out for their various uses. This process, while complex, is crucial to our modern way of life. The natural gas it produces powers our cities, heats our homes, and even cooks our food. The byproducts, those NGLs we talked about earlier, have their own important roles to play. Propane, for instance, is commonly used in heating and cooking, while butane can be found in lighters and portable stoves. So, the next time you flick on a light switch, crank up the heat, or fire up your grill, take a moment to think about the role of natural gas and its byproducts. From the unique shale formations of the Marcellus and the UTA to the natural gas that powers our cities, and the byproducts that find their way into our daily lives, the importance of this energy source cannot be overstated. It's a testament to human ingenuity, and our ability to harness the natural resources of our planet for our benefit. It's a story of energy, innovation, and the interconnectedness of our modern world.